everybody. Hello, I'm so excited to be here again today. Before we get going, I have a quick question for you. Do you feel like this upon hearing that your new task is to add authentication and authorization in your Angular applications? It's no fun, right? And it can be really hard to do. Well, never fear. Let me introduce you to the identity guardians and help demystify how they work behind the scenes and how we utilize them in our Angular applications. When we first think about authorization and authentication, though, we think of web apps, and that includes both Angular as well as the more traditional server-rendered applications. After all, we use the web for everything, right? But that's not the only place where we need to worry about auth. What if you have a handheld device and you want to play games with your friends, or you want to read on your e-reader? In those cases, you need to have some sort of authentication system as well. And what if you have back-end systems that communicate to each other, such as machine-to-machine, or you have maybe a microservice backend? In those cases, you don't have a user context, but you also need authorization there. Now, unfortunately, that would be a lot to cover, and so I can't do it all today. However, a lot of the concepts that we'll be talking about today do apply to each one of these use cases. So today, since we're at NG Rome, I'm going to focus on web applications. Now, this does apply to both Angular and other SPAs, as well as traditional server-rendered applications as well, if you're a fan of Java Spring Boot, for example. Whenever we talk about authentication and authorization, we always want to use the industry-recognized standards and the best practices that are out there. And that's using OAuth 2.0 for authorization and OpenID Connect, or OIDC, for authentication and identity. Both of these said are industry-recognized standards. It's best in class, and it is what is recommended for web apps to have best authentication and authorization security. When you think about OAuth, though, if you start reading into it, there's this one really confusing concept, and that's called OAuth flows. Which one do you pick? Well, they roughly correlate to the use cases. And so I want to demystify and clarify that today, that for web applications, we should be using an OAuth flow called authorization code flow with an extra extension called the proof key for code exchange, or PKCE. Now, I know, I said I was going to demystify auth, right? And here I am throwing around these big words. What does that even mean? Well, I want to call this out specifically because if you're looking up any documentation or any sort of blog content, you might come across recommendations for alternate OAuth flows for your web apps, and that might be outdated. Actually, it is outdated. You should always use authorization code with the proof key for code exchange. Just remember, PKCE is kind of fun to say, so you always want to include that. At a high level, this is how it would work within our Angular applications. Let's say you have a Tour of Heroes Angular app, and you want to have users log in, right? What you'll do is bring in an OIDC certified client library. Now, this is really important. You want to delegate the work off to this client library. And then you'll also have an identity provider. This is some sort of a software service that helps centralize your user's identity and manages it for you. And it's widely used by most large organizations and such. A reputable identity provider will support OAuth 2.0 and OpenID Connect, and it'll also have an authorization server that you'll connect to. So when you're ready to log in, the OIDC compliant library will redirect the user to log in on a web page that's hosted on your IDP. And it's going to pass in some parameters in the URL. You'll see something like response type, which is code for authorization code flow. You'll also see the client ID. That's some sort of unique identifier for your client, your Angular Tour of Heroes. And you'll also need a redirect URI, which is where the identity provider redirects your user back into your application when they successfully authenticate. And then lastly, you'll include some things like scope, OpenID for OpenID Connect, and offline access. And through a series of interactions, you're going to get back, what is this, 3 random strings? What are we supposed to do with this? How does this work within our Angular apps? Well, these 3 strings are tokens, and we get back the access token, the ID token, and the refresh token. The access token is for authorization, and it's from the OAuth layer. It's what we can use to get access to data and perform actions within our application. The ID token is from the OpenID Connect layer, and it's for authentication and identity. And it includes standardized identity information, which totally makes sense for something named an ID token, right? And then lastly, we have the refresh token. The refresh token allows you to extend the life of authorization and identity, so you don't have to keep having your users log in over and over again or do some ridiculous things with sessions. And it works by exchanging for new tokens. Now, these 3 tokens work hand in hand, and they combine and unify. And when they do, they form the identity guardians. It's like a shield that protects us. So how do these guardians protect us and our apps, and how do we utilize them? Well, let me show you how. We'll start off first with the ID token. So the ID token is for authentication identity, and it's from the OIDC layer. And it's kind of like having an ID card. So we'll have standard information that you might expect from an ID card, such as who issued the card, the Tour of Heroes company, of course, and some sort of an ID that binds this client to the token or this ID card. And we'll also, of course, need to know when it was issued and when it expires, which is always very soon. And then lastly, who this client is. And this is only valid for that Angular Tour of Heroes app. That's the client ID. Your OIDC compliant library will check all these things when your ID token returns and deem the user as authenticated or not. We can utilize this information within our code by conditionally showing logic depending on the authenticated state. That OIDC client library will have some method to get that authenticated state for you. So we can bring that in and use that in our control flow or however you want to display authenticated state. In the ID token, we also have information about the user. So we get their name, like I'm a programmer, right? Or perhaps what their role is. But if we take a look at that token, it looks like a jumbled mess. And that's because it's in JSON Web Token or JOT format. JOTs are a compact and secure way to transmit information to each other. And it's comprised over 3 parts. We have the header and the signature, which includes metadata about the token itself, including how it's encoded, as well as this large section in the middle called the payload. We can use the payload for our application. Now, I said that JOTs are compact and secure, but I didn't say they were confidential. So we can decode this and see something called claims. These are like a key value pair with information, and there's standardized claims, such as your name, as well as the ability to add custom claims. Now, these are information about the user that is pertinent to their identity and required by your software system. So they're very specific. You don't just add all sorts of claims to it. But knowing the person's role seems pretty pertinent to their identity. We can utilize this information within our Angular application to show a warm, friendly greeting to the user immediately upon authentication without making any extra calls to a user API or to get user profile, because this standard identity information is built right into the token. And now, a Tour of Heroes app wouldn't be anything without a tour, right? So let's say that somebody wants to start a tour, but you don't want just anybody to tour the app. You want to make sure that they have access to do so. So you may want to have a route guard. You can add a guard to your route definition and then define that guard by injecting the auth service and then getting the value of one of the claims, such as that role, and defining if they're a member or not. Now, this doesn't matter if you use the can match guard or can activate child. I don't know when you'd use the can deactivate for this, but it doesn't matter how it works. Either way, you can utilize the information within the ID token to do conditional logic. Next, we have the access token. The access token is from the OAuth layer, and it's for authorization. And it's primarily something we send to the API to get data and to perform actions. So it's kind of like a ticket that we can exchange to get more information. Whenever we use the access token to call the API, we'll send it wholesale right over to the API exactly as we received it from the authorization server. And in response, if you're authorized, you might get back that list of heroes and a 200 OK. Otherwise, you might get back a 401 unauthorized if your token is expired or you don't have the access levels that you need to perform that action. Or you might get back a 403 forbidden if your token is not valid or is malformed. The API, though, cannot necessarily inspect and look at the token itself because unlike OIDC and ID tokens, access tokens don't have to be in JOP format. It's actually opaque. So an API could say, well, okay, I have a token. Is it valid or not? Let me ask the authorization server and have the authorization server introspect it. And it can return information that the API can then utilize to determine whether or not to allow the user to get that list of heroes, for example. Whenever we talk about making a bunch of API calls and sending that same header over, well, that makes sense to use an interceptor in Angular's world. So what we will do is add the authorization header using the bearer scheme and then passing in that access token. If we take a look at the code for a functional interceptor, we'll inject the auth service, which should have access tokens and the ID tokens. And we'll set that authorization header using the bearer scheme and then clone it to the request and send it back. But we don't want to do that for all outgoing calls because that's dangerous. If you want this guardian to protect you and you alone, you must ensure it doesn't fall into nefarious hands by limiting the allowed origins. This prevents the tokens from leaking. Now, leaked tokens will allow villains to impersonate you, and that's no good. So you must ensure that it doesn't fall into those hands by only sending it to the origins that we trust. That's really important. And then lastly, we have the refresh token. The refresh token allows you to extend the life of authorization and authentication. So before it's expired, you'll have more access without making the user log in again. So it's kind of like getting a ticket to more tokens. Now, how this works is that your OIDC client library will send the refresh token back to the authorization server, and in response, get a shiny new access ID and refresh token again. So you're not exchanging one long-lived token for another long-lived token by keeping a long-lived refresh token. You want to keep it short and keep exchanging it. This is called refresh token rotation, and is something you'll want to enable on your authorization server. All right, so we talked a lot about all these different guardians and how they work independently and how it works within Angular, but now let's take a step back and see how this works all together, because there's a lot going on here. So we have our Angular app, and we have that OIDC client library, and we'll have our identity provider that has the OAuth 2.0 and OpenID Connect protocols. The OIDC compliant library will redirect the user to sign in on a page hosted by the identity provider. And you want to make sure that that authentication challenge is kind of challenging, right? You don't want to just have a really simple password or anything like that. You want to make sure that you're looking at phishing-resistant factors or ways that other people can't impersonate the user and trying to get their credentials and log in. Once that happens, you'll get back that authorization code. Then the client library makes a call using that code to the tokens endpoint to get back the ID token, access token, and refresh token. The OIDC client library then verifies the validity of the ID token, and then it'll deem the user as authenticated. But it's not done yet. In the background, the OIDC client library will continue to refresh the tokens and continue that authorization authenticated context for the user by exchanging the refresh token for those other tokens. There's nothing you need to do here, though, because it handles it for you. Now your code can kick in and utilize the ID token's claim values for that warm, friendly greeting, for example, and whatever else you might have in the standard identity claims, as well as utilize the information in the claims to protect views or routes or do other sort of conditional handling. Now notice here, your Angular application is only looking at the ID token and only getting information from that. Then, if it needs to get more information from an API or perform other actions, it's going to send the access token wholesale over to the API. The API will verify the access token, perhaps by communicating with the authorization server. Finally, when you're done touring all of the heroes you ever want to tour, you're ready to log out. Your OIDC client library revokes the tokens, which means that your authorization server will mark them as invalid, and nobody can then utilize them to perform other actions or try to get into your application. So in a way, your identity guardians continue to work for you even after you're signed out. I've mentioned all these different endpoints and all these different things going on. You might be wondering, wait a minute, that's a lot to keep track of. How does that work? Well, OAuth 2.0 and OpenID Connect has endpoint discovery. It's a discovery document that lists all the endpoints it might interact with, as well as capabilities of the authorization server. And you might have heard of it known as the well-known endpoint. I'm calling this out not because I think that you should be digging around in there and doing things, because you should let your OIDC client library do the work, but it's just good to know if you ever need to figure out what is it that my authorization server can handle. I've mentioned using OIDC certified products a couple of times here, and I want to clarify what that means. You always want to start with a reputable identity provider, by which I mean it needs to be an identity provider that supports OAuth 2.0 and OpenID Connect. It doesn't matter which one it is. There's a lot out there. And luckily, there's a list for us. So we can go to this website, openid.net/certification, and it'll list all of the identity providers that are certified to work for us. And for your OIDC client library, you can use the SDKs provided by your identity provider, or if you want to go use an open source one, there's a list of the OIDC certified client libraries as well on that website. We're awfully lucky in the Angular ecosystem that there's 2 open source client OIDC certified client libraries that we can pick from. One of the maintainers is even here at the conference today. One key note about making sure your identity guardians are strong and at full power is to never build your own auth. Always, always use OAuth 2.0 and OpenID Connect. Use these industry-recognized best practices and use a reputable identity provider. And you don't even want to write your own OIDC client library. Just because you know that those well-known endpoints, and just because you've read the spec, don't do it. Always use an OIDC certified library. It's been vetted and tested for you, lest your guardians fail to protect you. I hope this introduction to the Identity Guardians helped demystify how they work behind the scene, as well as how we utilize them within our Angular applications. I have this QR code here. You're welcome to check out these slides. I will warn you, since I generated this with Keynote, it's a little quirky, so don't ignore the animations, but the content is all there. And if you want to dive in deeper into how OAuth 2.0 and OpenID Connect work with SPAs, I have this link for how authentication and authorization work for SPAs as a blog post. It allows you to read along as well as follow along in an application, and you can dig around and look at the dev tools, look at the network calls, local storage, things like that. I will warn you, the video is for React. Don't judge me. I'm supposed to, support all JavaScript frameworks, so you can easily apply this to Angular, though. And then lastly, feel free to reach out to me at Alisa Duncan. You can find me on a variety of different social channels. I love making new NG friends and talking about auth, talking about identity and access management. And I don't know, give me your information on your best tips and best tiramisus that I should hit up tomorrow before I leave. So that's it. Thank you very much.
Thank you.